UFO party at Phil's house with Dean Fagerstrom.
Got it?
Yeah.
Are we rolling?
Rolling.
Okay. Now, you're going to see a few examples of 32 diagrams that Dean did under certain circumstances which today to the scientific world remain totally unexplainable. This first one here is probably a very interesting one called a photon accelerator. Back in the early 80s, you know, the question was by people of the academic world, especially in physics, is how do you accelerate a photon? And according to knowledge then, you don't accelerate a photon. What this device seems to do, seems to take photons and accelerate them to a stage where it's not accelerating them in speed, it's accelerating them in energy levels. And similar devices are known today and used in various particle accelerators. However, when Dean did these diagrams, these devices were completely unknown. Now, some of the things, the interesting things that you see here is that the way this is coiled. And that particular method of coiling was looked at by an electronic engineer who said that it's a very interesting way and new concept, the way you would make a coil to produce a magnetic field and electric current. As a matter of fact, that coil has been copied a number of times and proven to work. You see close-ups of that coil in the section. And a lot of things, of course, here, like some of the scientists at Northwestern University said, especially the late Dr. J. Allen Hynek, is that they're very interesting to look at, but there's not enough information exactly to tell you how to build one. Because some of the components there are actually you can't find. For example, like the little ball here, the red ball here that you see here, that is some type of substance that's contained in a magnetic field, and it actually acts as a pusher or an inducer to generate the energy field. And you see that device in that power source in a lot of these devices, and it seems to affect some of the molecular components on a subatomic level. So that's number one. But one of the things that's totally got me into these diagrams, which was pointed to me by a master draftsman, it says that a lot of these lines are totally symmetrical here and here. You know, and an artist can appreciate the quality of the work doing here. And a lot of these diagrams were looked at, by the way, by a microscopic analysis. And the only flaws in the lines that are there are the flaws from the pencils that Dean used, which we'd naturally see. Dean, would you like to say anything about it?
Well, the only thing I can actually say is that the circumstances of these drawings having come into existence is quite a story in itself. And as to their particular function and reason, I don't have much of an answer for this as well. I think it's been explained with a little more precision by Phil than I myself could give it some credence, although there's only one instrument that I can discuss later on as we come to it, because I happen to have seen a manifestation of its action and what it does.
Okay. Now, the different colors obviously mean different energy levels being produced. However, what type of materials are being used, what type of materials, metals or whatever, is completely unknown. This is actually an area here will create a rotating magnetic field when these particles are accelerated through this coil to keep the polarity aligned, okay, which would be very, very important, unless the particles would fly all over the place. So the technology that you're seeing here is technology that is available today, but in 1960s, when Dean did these diagrams, it was science fiction. It wasn't even considered by science fiction. Okay, we're going to pause. Ready? Mm-hmm. Okay, this is a diagram, and it's not as colorful as the other one, but it's very important. It's of a three-dimensional viewing screen, and it shows the optical components arranged to create a three-dimensional image. When Dean did this diagram, the idea of three-dimensional computer screens, three-dimensional images in the theater was totally unknown. Nobody knew how to do it. But if you compare the optical arrangement of the components and the distance here in these devices, you'll see they bear a striking resemblance to three-dimensional screens that are created today. Okay.
Go ahead.
Okay, this device here, it's not exactly sure what it is, but it's a device that, as far as we can see, that people have looked at it, has some of the components to induce cold fusion. Okay, but how it's done, what materials are, is completely unknown. Who knows? Like I'm saying, somebody may be able to see this in the near future and get an idea of a stumbling block and discover totally something new. And I think really that's the purpose of these diagrams. Here's some of the ideas. Okay, this is a helical coil, and once again you see the same system in the system here, and where this winding of the wire is done in a particular core. And this type of device is used. It's very common in electrical devices today and in the 80s, but in the 60s it was not used. It's used to intensify magnetic fields and currents. And this device was actually built by a fellow up at MIT who was studying at MIT, who was an MIT graduate, who was an electronics engineer, who passed away recently. And he built this device, and he was amazed as to the arrangement of the coil, something once again totally radical. He built a device and he put a current through it, and an electromagnetic pulse came out through the other side, would register 10 times normal above normal than any other device. However, after about 2 seconds, the device burned out. When I went to Dean and told him this back in a long time ago, I can't remember how many years, I said, well, he used an iron core and steel core components, and Dean was saying something they should use magnesium and beryllium or something, which would be an exotic combination at that time. But this gives credibility to the other diagrams because this is simple enough to be built, and it was built and it did work. However, once again, we don't have the materials that were used. They may be alloys that are totally unknown to us. Okay.
Good.
Okay, this is some type of optical system, and it says it's its actual size, and it seems to be used for viewing maybe from long distances far away, maybe even out in space or whoever knows where, and the image is brought in through a lens-like system, and it almost looks like this is very comparable to what's used in modern days on photomultiplier tubes on telescopes today, which in the 60s was not used. Okay? So this is very similar to what's going on here. So this image is collected by a lens, the light is focused through and bent through and intensified in this area, and the image is formed. And with a device like this, I mean, theoretically, you could be out in orbit somewhere and view down and image a penny on the ground and see the detail and the scratches of the penny. So, so we're dealing with something very interesting here. Can you want to say anything about this? You know something about this.
Well, not this particular one, actually, as the person under the particular influence and the circumstances which brought about the drawings in the first place, I didn't take any opportunity to ask specific questions because I was intent on doing it correctly as I was being guided to do it. But I did see the same thing in terms of the effects that Phil just described, and I remember that our satellite pictures that came from space back in the Israeli War in 1967, it was said that an Israeli major was exposing his watch on his wrist, and they could tell the time, and that's how good the resolution was. Wow. And I think that this probably exceeds that many times, where it correctly fashioned as Phil was formerly explaining.
Okay. A diagram that blew a lot of people's minds for it to be done in the 60s. Here we're taking the hydrogen nuclei, the nucleus of a hydrogen atom, and it's being divided into a number of subatomic particles. And the arrangement of these particles here and the definitions, of course, Dean is identifying with molecular domain and so on, agent domain. But that's irrelevant to what's going on here. Is that what's happening here? You see the nucleus of a hydrogen atom, and Dean is actually back in early mid-1960s is showing the hydrogen nuclei, when back then everybody thought that the hydrogen nuclei was just made up of one proton, and a